All right, so for our first section on this worksheet, it just says simplify each expression, leave the numerator in standard form. That means general form, like 2x cubed plus 3x squared, whatever, and the denominator in factored form. Now, honestly, I don't care if you leave the numerator in factored form. The goal is just to be able to recognize both. We have an AP test at the end of the year. There will be multiple choice questions. You have to be able to realize, like, oh, if I factored this result, I would get this answer that they have on the test. Okay, so with that said, recall that when you're reducing variables with exponents, you subtract their exponents, but with coefficients out in front, we are just reducing 35 over 21. Those both divide by 7. So I'm going to start out with 5/3. Subtract 7 minus 2, x to the 5th. 4 minus 7 is -3, so instead of writing y to the -3rd, I'm going to write y to the 3rd in the denominator. That's that one. This one's nice and easy, factored out for us. X plus 2 over x plus 4. And please remember, there are, I always call this like invisible parentheses around an expression in a numerator and a denominator. You are not allowed to cancel or divide x's. You're not allowed to divide 2 over 4 and reduce that because these numbers are tied. X plus 2 is tied together, x plus 4 is tied together. You cannot, it goes against order of operations to simplify that any further. For our next one, I see a GCF of 7 in the numerator. The denominator is a trinomial. We've got to multiply to 12 and add to 7. X squared minus 9 factors further. X plus 3's can divide out to 1. So here's one where I can leave this 7 times x minus 3 over x plus 4. I'm perfectly happy with that answer. Or if you want to go the extra step to distribute it, you could. But there's no difference. I don't consider one of these more simplified than the other. So it does not matter to me which answer you choose. Again, if the multiple choice answer is the second version and you have the first version, I sure hope that you'll recognize that they go together. Okay, number 4, always look for GCFs. If you have a coefficient other than 1 in front of your x squared, that's your first hint to be like, is there a coefficient or is there a GCF? There's not always, but if there is, you will save yourself a lot of time trying to figure out what the multiples are going to be. And luckily I can take a 3 out of both of these. So the 3 that I factored out is allowed to divide with the 3 that I factored out top and bottom. And then I can factor each of these trinomials. 5 and 4 are going to multiply to 20 and add to 9. And 5 and 1, I need to get positive for us. It's got to be plus 5 minus 1. So the x plus 5's cancel. And I've got x plus 4 over x minus 1. All right. Now our next section involves operations. So these were just single expressions to simplify. So now we're performing the operation, simplifying if possible. These first few are pretty nice to us because I'm trying to add 2 fractions. The fractions already have a common denominator of 7y, so no adjustment needed. It's just 2x plus 5x. So you do need to make that 7x over 7y. And you are allowed, because this is multiplication, if this was 7 plus x, 7 plus y, I couldn't do this, but 7 times x divided by 7 times y, you can cancel the 7's. X divided by y. Same thing here. We have the common denominator is already set up, w plus 2. But be careful here. When you say you're taking this, remember those invisible parentheses. You're taking this binomial and subtracting this binomial. There are parentheses here that you need to distribute the negative through. That is the most common mistake, is not distributing the negative to the second term. So it should be 4w minus 9 minus 5 plus 3w. And then you get 7w minus 14. Now, I can leave my answer like this because I'm kind of factoring it in my head and realizing nothing's going to cancel. But if you're just itching to factor that, or you just want to be super sure, factor a 7 out. W minus 2 does not cancel or divide to 1 with W plus 2, so either one of these answers is acceptable. Number 7, this is supposed to be a multiplication symbol. That's a dot. So I'm going to start, when it's multiplication, there's no multiplying by a reciprocal. You just factor what you have. And please be careful with when 6 is the end number, pay attention to what you have here, because 6 and 1 can get you 5, 2 and 3 can get you 5, and one of those is correct and one of those is wrong. So it's got to be 2 and 3, because if you did like 6 and 1, one of these would need to be negative for you to get 5. And the problem is they're supposed to multiply to positive 6. So you will see this trinomial or x squared, just different variations of this, x squared plus 5x minus 6, so that you do have to use that other factoring. I will put this on a lot of speed quizzes this year just because it's such a common one to factor in correctly. I want you to get used to seeing it. Difference of squares. Remember, we do not need a common denominator to just multiply fractions together. If I say what's 1/2 times 1/3, the answer is 1/6. You do not set up a common denominator. So we're just dividing out what we can. So x plus 2 can divide with either one of these. X plus 3 can divide out. So there's actually no denominator left, or it's just 1. So we just have x plus 2 times x minus 2. I would leave it like that. If you want to follow the rules that the direction said, make it x squared minus 4, because that's technically a numerator. I'll take either one. Number 8 is division. So we're going to need to remember to flip or write the reciprocal of the second fraction. But first I'm going to start factoring the first one. So I can take an x out of x squared minus 4x. I can take a 2 out of 2x plus 16. Then I'm going to say multiplied by. Now this is what I'm about to factor up here. So I need to multiply to negative 32 and add or subtract to 4. So it's going to be x minus 8, x plus 4. Oh, nope, sorry. It's going to be x plus 8, x minus 4 to get positive 4. And then x squared minus 16, I've flipped this so it's in the denominator, x plus 4x minus 4. So every division problem, remember, we change to a multiplication problem. And then you see what cancels. So x plus 8 and x plus 8 divide to 1, x minus 4 and x minus 4 divide to 1. You're left with x times x minus 4 in the numerator and 2 times x plus 4 in the denominator. I'm not going to bother writing the second form of that. Again, there's really no reason to take it a step further if you're just answering a free response like this. Okay, we are adding for number 9, so we need a common denominator. So I'm just going to factor below these just to look at what I have. So one denominator has x plus 3x minus 3. And then the other denominator is x plus 3 times itself, or x plus 3 squared. So remember, the least common denominator is really the least common multiple. Like if I said I want you to add 1/2 and 1/4, the common denominator is not 2, it's 4, right? You would do this. The bigger number was the least common denominator because that's the least common multiple, the first number that both 2 and 4 multiply to. So keep that in mind here. We need to have x plus 3, but we need to have x plus 3 squared because x plus 3 squared is the bigger of those two options. It's like the 2 squared versus the 2. We also need this x minus 3. Don't forget about that. All right, so we should be saying, well, what does each fraction need to get multiplied to achieve that common denominator? So the first fraction has a single x plus 3x minus 3, but it needs that squared there. So we're going to multiply by x plus 3, top and bottom, to make that happen. So 3x squared plus 9x. The second fraction has the x plus 3 squared, so we need it to have the x minus 3. So we multiply that in, top and bottom. Distribute this positive 5 through. So plus 5x minus 15. And then clean it up a bit. So we've got 3x squared plus 14x minus 15. Never spend time distributing or foiling your denominator together. There's no point into doing that. Does this factor? Oh, I don't know. The question is really, here's the question. Are either of the factors x plus 3x minus 3? So if this is a 3, then this would need to be a 5 to get the 15. Is there any way that's going to give me 14? Let's see. 9x? Oh, I think so. 5x. Oh, but you know what? It only gives me 14. This is tricky. Only gives me 14 if those are both positive or both negative, but I need a negative 15 here. So it can't be that these are both plus. One of those needs to be minus. So very close to being factored, but it's actually prime. All right, so this is the final answer. That's as far as that simplifies. Number 10 is a subtraction problem. So first let's factor our denominators to see what we're working with. So for 30, we could have 5 and 6, right? To get 11 in the middle. 20 is going to be 5 and 4. So this common denominator, I don't see any squareds involved, but you have to have one of each factor represented. So you need an x plus 6, you need an x plus 5. They both have that. So we don't write it down twice, just once. And then we need an x plus 4. All right, so the first fraction has the 6 and the 5. It needs to get multiplied by x plus 4 top and bottom to get that complete denominator. So that's going to be x squared plus 4x. The second fraction has the 5 and the 4. It's missing the x plus 6. So we go ahead and multiply that in there. And remember, this is a negative 5 that we're distributing through. So minus 5x minus 30. Okay, and then that is x squared minus x minus 30. Now 6 and 5 are going to factor. So we do need to factor our numerator. This is the reason that we combine these terms, is so we can see, does this reduce even further? It would have to be x minus 6, x plus 5 to give you negative 1 in the middle. And I can see that the x plus 5 factors in the numerator and denominator will divide up to 1. They'll cancel. So the final answer is x minus 6 over x plus 6, x plus 4. Okay, complex rational expressions. Now remember, we talked about 2 methods to doing these in our notes. I'm going to use what I called the shortcut method. But if you don't like that, remember, you would be, I suggest that you try it, because once you get the hang of it, it does make the problems a bit faster, I think. But if you really are having trouble wrapping your brain around it, remember, it's this fraction divided by this fraction. So you can rewrite the problem and then work on it like you would have on the front page. And we should get to the same answer if we've both done our math correctly. Okay, so I'm not going to do that. I'm going to factor everything as is, and I'm going to multiply top and bottom by the LCD. So first let's factor. Y minus 3, y plus 2, y minus 7, y plus 2. Oh, and there's a little bit of simplifying already in here. And then y plus 5, y plus 1, y minus 7, y plus 1. Okay, now this one's pretty nice off the bat because before you do any sort of LCD, notice that y plus 2's cancel, y plus 1's cancel. So now it's y minus 3 over y minus 7 over y plus 5, over y minus 7. Now, actually on this one, I guess it doesn't matter how you show this, but just to keep consistent with my methods, I'm going to say, I could say multiply by the reciprocal of the bottom fraction, or I could just say they both have this y minus 7, so I'm going to multiply by y minus 7 over y minus 7. And if I do that, the y minus 7's cancel, and you're just left with y minus 3 on the top. Down here, the y minus 7's cancel, and you're left with y plus 5. So is that shortcut much of a shortcut? In this problem, not really. It's not really any different than flipping the second fraction and going from there. Okay, for this one, again, you can set up common denominators separately and then work on each part separately. Or you can say, I have an x and a y and an x and a y. So the common denominator has to be x times y. This is one where this is going to be shorter using the shortcut. When you say you're going to multiply by xy over xy, you're multiplying by 1, so this is legal. And you're multiplying this into a binomial, so distribute it through. So when you multiply 5 over x times y, the x's cancel, and you're left with 5y. When you multiply 2 over y times xy, the y's cancel, you're left with plus 2x. So the top of the fraction is finished. And so the benefit of this is we have cleared the denominator or the fractions up there. Same thing down here. If I distribute the xy through, the x's cancel, I get 3y. And then in the second term, the y's cancel, and I get 4x. There's nothing to factor out of these two problems. So that's it. For number 13, I'm going to use the shortcut again. What's the LCD? So the only denominators I see are 1s, so that's irrelevant. I see x and x squared. And remember what we talked about. If you have like 1/2 and 1/4, 1/4 is the common denominator. Or 4 is the common denominator. It's not the 2. It's the bigger number. It's the 2 squared that's the common. So the LCD for x and x squared is x squared. Because you can multiply x by something to bump it up to x squared, but you can't multiply x squared by a whole thing and get it to bump down to x. All right, so multiply x squared through. 3 over 1 times x squared is just 3x squared. 1 over x times x squared would become plus x. Same thing in the denominator. 9x squared. 1 over x squared times x squared is 1. This is minus, so minus 1. We can do a bit of factoring. There's a GCF of an x in the top, so 3x plus 1. There's a difference of squares in the denominator, 3x plus 1, 3x minus 1. So 3x plus 1's cancel. And it's x over 3x minus 1 for our final answer. Okay, what about 14? So I don't want to rewrite the whole problem just to show the factored denominator. So I'm just going to, the only factoring I see is right here. A minus 5, a plus 2. And if you look at all of the denominators, there's an a minus 5. There's an a plus 2. This already has both of those, so no new factors introduced down here. So that is the common denominator for the entire complex fraction. So that is what we multiply by. So in the numerator, 4 over a minus 5, the a minus 5 will cancel with the other a minus 5, and you'll have 4 times a plus 2. And then there's a plus sign. When you multiply the top fraction by 2 over a plus 2, the a plus 2's cancel, and you have 2 times a minus 5. Down here, same thing. Now this 2a fraction, this has both denominators, so they'll both cancel out and you'll just be left with 2a. And then for the second term, the a minus 5s will cancel and you'll have plus 3 times a plus 2. Okay, and then we've got some cleaning up to do. This is 4a plus 8 plus 2a minus 10. I need to clean up down here. 2a plus 3a plus 6. The reason we're doing all this distributing is to see if anything will, once combined, will we be able to factor and cancel anything else? Even though I can factor a 2, and that would leave me with 3a minus 1, factoring a 2 out is not going to allow me to cancel with the 5a plus 6, so I'll just leave my answer like this. You could factor a 2 out if you wanted and give that as your final answer as well. Okay, last problem. Looks like we have to pay attention here. This is division, by the way. Division right here, and then addition. So order of operations says you need to do division before you work on addition. So we are first going to work on this chunk of the problem right here. So let's begin by factoring. 4a squared and 9b squared to get 12ab in the middle. I'm going to guess it's 2a and 2a, and then probably 3b and 3b. Let's double check the math on that. Yeah, 6 and 6, and they both need to be minus to give me the minus 12ab. The bottom part is a difference of squares. 2a plus 3b, 2a minus 3b. And instead of divided by 3b minus 2a, which is currently over 1, I'm going to multiply by 1 over. Now look at this, 3b minus 2a. In all of these, the a comes first. So maybe it's in our benefit, or maybe we'll see this more clearly if we say, let's factor in negative, or you could have put the negative with the 1. Factor a negative out of that to make it 2a minus 3b. That will show you more clearly what you're allowed to cancel with and the fact that there should be a negative sign or a negative 1 left over. And then we haven't done anything with the second part, but I do just want to factor its denominator just to see what we have going on over here. So 2a squared has to be split into 2a and a. 21b squared, so it's got to be 7 and 3. If we put the 7 out here, we'll get 14 and 3, which will give me 11. So minus 14 plus 3. All right, so let's cancel some items here. I have a 2a minus 3b over a 2a minus 3b. Those divide to 1. 2a minus 3b divided by this 2a minus 3b. It does divide out, but it divides out to negative 1 because there's a negative there still. Okay, so we really have, let's move this negative up here. We really have negative 1 over 2a plus 3b plus 7a plus 2b over 2a plus 3 times a minus 7. I should be putting equal signs here, sorry. All right, now what's the common denominator? They both have, oh wait, did I drop a b somewhere? Sorry, this should be b's. B, 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 b. I feel like I do that every year because it was 21b squared. So they both have a 2a plus 3b. And the second fraction has an extra factor of x minus 7b. So the first fraction, we've got to multiply by a minus 7b. So negative 1 times a minus 7b plus 7a plus 2b. Okay, distribute and combine here. Negative a plus 7a is 6a. Positive 7b plus 2b is plus 9b. And those have a GCF that really seems like it ought to be able to cancel. So let's see. Take a 3 out of the numerator to get 2a plus 3b. Yep. And that's going to cancel with the 2a plus 3b in the denominator. So this one, once you get through it, kind of satisfying, right? It gets all the way down to just 3 over a minus 7b. So all the way from this mess to that, which I think is kind of fun. All right, if you have questions, please come to office hours or ask at the start of class so we can go over this assignment.